Here we are again to do another little short video on why angles matter and why angles to surfaces are important. And by the way, everything in your field of view has a surface. Everything, from the ground to anything in the sky, any object you look at has a surface. And your angles to those surfaces make a difference in how you see things. So I have 7 squares here. They're not quite square, but 7 similar squarish areas. So from this angle you have a pretty good view of all of them. They're pretty similar, but this would be like me standing somewhere off looking at a building with different levels. Now if I was close to the building and looking up, you'd have a whole different result. So here we're looking straight on. 90 degrees is about in the middle. And we're looking at a building. But now let's say I go to the bottom of the building and I look up. Are those squares going to stay squarish? Are they going to take up less visual space, especially the closer to the top you get? Look, you can even see the sides slanting in when I'm dead center. The left side and the right side are both slanting inward. If I'm closer to the left side, the right side is slanting inward. If I'm closer to the right side, the left side is slanting inward. So obviously the black space at the top and the orange space next to it take less visual space than the green and the blue at the bottom. But now I'm going to get even closer to the building. My angle to the top is getting very acute. Not obtuse, which Farmer's Boy, by the way, was incorrect. I had no obtuse angles in the one video from yesterday, but that's Farmer's Boy for you. But now, as I get closer, you can hardly see the black. It's just a little thin line. But the blue and the green here at the close end, you can still see quite a bit. But none of they don't look square anymore, right? But of course, as I move away, my angle to the building changes. And those at the bottom are getting bigger, the top are getting bigger, but are still smaller than the ones at the bottom, even though they're all the same size. The angular size of each section is equal, but not when you view them from acute angles. Then suddenly they don't seem so even, do they? Okay, now I made 2 big squares. These are squares. And we're going to show how a visual angle makes a difference in how you see those squares in your field of view. Here, they take up a large portion of my field of view, right? Here, we can even move it up closer. Look, they take a big portion of my field of view. Almost from top to bottom, right? Now, what are those squares going to look like when I tilt the board down? Right now it's like I'm looking straight at the building from a little ways away. So my 90 degree would be about in the center. So any angle upward or any angle downward will have an effect on what you see visually, because the angle becomes acute. So anyhow, I'm going to tilt the board. I know this is all your guys' favorite thing, but you guys don't seem to comprehend, so we have to repeat and show this. By the way, Flatzoid recently did one that had something like this in it too, where he colored the things to show you how they take up more or less space when your visual angle is acute. And I've done it before in another video that I made a long time ago. But anyhow, you're going to see these squares now don't look quite so square, do they? And now the left side, if I'm more in line with the left side, it looks straight up and down. The right side looks like it's slanting inward. If I go to this side, it's the opposite effect. The left side looks to slant inward while the right side is straight. Now you can see the red, I've only tilted a little ways, but the red has the appearance of being smaller than the blue, even though they're the exact same size. So as I get more and more of an acute angle to it, that red is just taking up a pretty small space. The blue is much bigger space. Remember, they're the same size. And this is the kind of thing that Jose and gang doesn't seem to comprehend. They think just because the angular size of all those are the same that you're going to see them the same, but they're not. Acute angles change how you see things, acute angles to surfaces. And remember, I said everything in your field of view has a surface. Those are gift boxes on the table here, and they have a surface. The fence in the background has a surface. This is a surface. This is also a surface when it's straight up and down. The boxes have a surface there. If I had my camera higher, of course you can see the surfaces here, surfaces of the table. Everything has a surface. If there's an airplane flying in the sky, it has surfaces. How your angles to those surfaces are determines what you see in your field of view. And once again, remember, your field of view is determined by elevation. And the higher you are, the wider your field of view is, with far more depth and distance at center frame. But once again, acute visual angles, it compresses the information into less, we'll just call it pixel space. Take an angle measurement to these two squares. Count the pixels. Which one has more pixels? I have an angle to both surfaces, but why does the back or the top one, the red one, look so much smaller than the blue one? Sucks to be a Globie. The stuff that you guys have to pretend to believe.